So I'm really interested in real zeros, okay? I don't care about the complex zeros, right? And how am I going to know I get a complex zero? I'm going to get down to quadratic formula, and I'm going to use, I'm going to get down to a quadratic, and I'm going to try and factor. If it doesn't work, I'm going to try and complete the square or use the quadratic formula. And if I see I get a negative in my radical, then I know it's a complex zero, and I'm going to ignore it and say, okay, I'm done, stop. So, but when we get to real zeros, we could be talking about rational zeros or irrational zeros. And I can't really see myself making you do one with irrational zeros, but I will on the test, but I will look at one today, okay? So our rational zeros, believe it or not, come from this theorem here. If P of x has rational zeros, meaning fractions, right? If P of x has rational zeros, then they must be plus and minus factors of the leading coefficient of the constant over factors of the leading coefficient. So, for example, the one we just had, right? Remind me. I had. Please remind me. I had x to the fourth plus dot dot dot. Yeah.
Plus 4x cubed plus 2x minus x plus 6.
Yeah, plus 6. So you can see my leading coefficient is 1, and my constant is 6, right? So the possible rational roots, I like to say rat roots, sorry, possible rat roots are coming from plus or minus 1, 2, 3, and 6 over plus or minus 1. And so, so obviously that is 1, 2, 3, and 6. And so that's the only possible way I could get a rational root out of it. It's the only possible way. And it should seem a little bit like, what the hell are you talking about? But if we take something, right, if we take something kind of complicated in that sense, so let's say like 2x minus 1, x minus 3, and 3x minus 4. Who cares, right? So I'm just making this up. So let me start distributing this out. What do I get? I get a 2x squared. I get a minus 6x, a minus x, and a plus 3, all times this 3x minus 4, right? So I get 2x squared minus 7x plus 3 times a 3x minus 4. So I'm now going to distribute the 3x, and I'm going to distribute the 4. Now, what are my roots here, by the way? What are my roots here? What's my 0 here?
Is it 1/2?
Good. What's my second 0 here?
3.
3, and the last one?
4/3.
Beautiful. So we know what our rational roots are, right? Because I started with this thing factored. But I want to go see what happens when multiply this out and I look at my leading coefficient and my constant term. Right, so here, what do I get here? 6x cubed minus 21x squared plus 9x minus 8x squared plus 28x minus 12. So I get y equals 6x cubed minus 29x squared plus 37x minus 12. So you can see I already knew what my roots were, but I want to see if now, and it's obvious that those are going to happen inside of this little theorem. I need factors of 12, 1, 2, 3, 4, 6, and 12 over factors of 6, 1, 2, 3, and 6. And I have to consider the plus minus of them, okay? So what did we say our roots were? We had a 1/2, right? We had a positive 1/2. We had a positive 3, and we had a positive 4/3. I just want to show you that those are in there. There's the 4/3. There's the 3, and what? 1/2. Got it. They're all there. So it's pretty obvious that it's got to come from those n pieces, the coefficients of the beginning and the constant term. Now, how can I remember that the leading coefficient's got to be downstairs? Why does the leading coefficient have to be downstairs? Let me get my crickets ready. Why is it that the leading coefficient must be downstairs?
I think it's because it has to do with, oh, wait, no, never mind.
Can you hear the crickets? I'll make it louder. No. I just got an answer in the chat. I'll just say no.
I'm not sure.
Yeah, that's not it. That's not it.
Does it have anything to do with part to whole, or am I just guessing?
Say again. Does it have anything to do with
Part to whole or whole part? Like
no. I like that. No. Well, what can't be downstairs? In a fraction, what number can't be downstairs?
0.
0. Can my constant term be 0?
Yeah.
Yes. Can my leading coefficient be 0?
No.
No, because then it's not there, and then it's a different degree polynomial, right? If the leading coefficient is 0, it's not the leading coefficient anymore. The next one in line is the leading coefficient. So I can't divide by 0. So that's the way I always remembered that it was the factors of the constant term over factors of the leading coefficient, right? And plus or minus all of them. Now, the last bit of theory to talk about, and I don't have much time left here, is René Descartes' rule of signs. Okay. So math majors, I would ask you to read it. I would say computer science majors should read it. Everyone else can just skip it. And I know it seems like I'm picking on the computer science students, but I am, because I was a computer science major, and I know this stuff is important for you to look at. But let's just talk quickly about René Descartes' rule of signs. So if you've heard of René Descartes before, I think, therefore I am, if you've heard of the Cartesian plane, the XY coordinate. So this guy was did a lot of math as well. But what it's basically saying, what Rene Descartes had discovered, just trying to find that part of the book, sorry. Oh, yeah. So when I reduced down and got a quotient and then reduced again, they're calling those things depressed equations. Right? So, read the book. I don't use that language. I hate going to the doctor because every time I do it, my tongue gets depressed.
You should.
That's a good one.
You should bring the crickets out for your own jokes.
No, I used to have a rim shot, right? That's what I'll get. I'll work on that.
Oh, yeah, get another one of those.
Yes. All right, here it is. So Rene Descartes' rule of signs says, if I take my function and I just look at the change in sign, so you can see my screen, right? F of x is 2x cubed plus 11x squared minus 7x plus 6. And if I just look at the change in signs, so it's positive, positive, negative, negative. So changes once, changes from positive to negative one time. That tells me how many positive roots there are. So if I'm looking at this horrible thing, if I'm looking at this horrible problem here, right? Oh, I'm sorry. It tells me how many positive roots, or plus 2 positive roots, plus 2 more positive roots. So since I got one sign change, there could be 1 positive root, there could be 3 positive roots, there could be 5 positive roots, etc. But I know I have at most 3 roots, right? Right? It's an x cubed problem. So Rene Descartes' rule of signs says, look at the sign changes in the function itself, and it will tell you how many positive roots you'll have plus 1. Plus 2. So I could either have 1 positive root or I could have 3 positive roots. I already know I have 3 positive roots. If I put in the negative x, right, and this one, and now I count my sign changes. So now look at this function. Can you see in the second paragraph here? I put in negative x and I got negative 2x cubed plus 11x squared plus 7x minus 6. I have 2 sign changes there, right? So 2 sign changes there. So I'm going to have 2 negative roots, or 4 negative roots, or 6 negative roots, always plus 2. So pretty crazy, right? Pretty crazy that.
What do you mean? Sorry to interrupt. What do you mean plus 2? Do you mean that as like a constant?
When I put in a positive x, I got a 1 sign change, right? In the original function, it's got a positive x on the inside. My signed SIGNs change only once. I go from positive to negative, so I change once. So that means there's definitely possibly 1 positive root. But plus 2 means I could have 3 positive roots. Plus 2 more, I could have 5 positive roots. I can't here because I'm an x cubed function. I can only have 3 roots. When I put in the negative, it's telling me if I count the sign changes, it tells me how many negative roots I could have. And so, and this is Rene Descartes' rule of signs. So we're not expecting you to do this, but it's quite interesting how he came up with it, and then so now what is that saying to me? I don't know what roots are there, right? So I don't know. I didn't look at the curve. That's what I'm saying. I'm pretending I didn't look at the curve. I didn't make this thing up. But I can try and figure out how many positive roots I could have, right? trying to figure out how many positive roots I could have, how many negative roots I could have, etc. So, and so that's the theory, but we're not doing that. How are we doing our problems? We're going to graph the function, right? We're going to graph the function. We are going to find a root, start to synthetic divide to figure out factors, chip away at it, right? Keep using that, what the book calls a depressed equation, or that new quotient from the synthetic, right? And then get it all the way factored if possible. All right, let's do one more problem and then quit for today. I want to do one with some irrational roots. So give me 1 second. So just did a quick Google search because I don't want to make a mistake. Give me 1 second. Here we go. All right, here we go. So I got a problem here. So last one for today, okay? So I don't think I'm going to make irrational roots happen on your test because MathXL sucks. But my function here is 2x cubed minus 5x squared minus 3x plus 9. And I already know that my possible rational roots, right, are coming from 1, 3, 9 over 1 or 2, right, plus or minus that. So that's giving me a quick hint at where I should be looking for my roots on my screen, right? So I want to graph this because that's how I'm asking you to do the problem. And then I'm looking for, what am I looking for? I'm looking for where I'm going to do my synthetic, and it's going to come from what? Plus or minus 1, plus or minus 3.
Professor, I have a question.
Yes, go ahead.
Why did you not include 5?
For what? On this problem right here?
When you were finding the possible rational roots, why did you not include the 5 in the function?
Yes, so I only am looking at the constant and the leading coefficient. So the constant factors are on top, leading coefficient factors are downstairs. Right, so I can have a 1, a 3, a 9, a 1/2, 3/2, or 9/2. So I'm looking for one of those places on my graph. So let's go to the graph. Where is my Desmos? There it is. So I'm going to this graph, and this is how I want you to do this, right? 2x cubed, oops, y equals 2x cubed minus 5x squared minus 3x plus 9. It's not quite clear where I'm hitting one of those roots or not. Do you agree with me? It's not quite clear to me which one of those roots, but it looks like possibly I could be getting, what number do you think?
1.5.
3 halves, yes? 1.5, I don't know, 1.5, yes, it looks like 3 halves. So that's these rational roots are going to help us decide on which one of these is possibly there if I can't quite see it on my graph. Of course, I could cheat on my graph on Desmos, right? I can put in 3 halves, comma 0, and see if I hit the function, and it looks like I do. And again, you can plot points on your TI-83. You're just going to have to look up the process because it takes a bit of work. So I'm going to start my synthetic with 3 halves. Everybody with me? Anybody not with me?
With you. With you, yeah.
With me, good, good. I got my chat open, so if you're not with me and you want to ask something, please let me know. So 3 halves with what? 2, -5, -3, and 9, right? Synthetic division. And I'm going to bring down my leading coefficient and multiply, right? I multiply here, and what do I get? I get a 3, and then I add here, right? I'm going to add here, so I get a -2. Yes, everybody with me? And rinse and repeat, right? So when I multiply, I get what? -3. Yes? And when I add, I get -6. And when I multiply, I get -9. And when I add, I get 0. Whoa, nice. It worked. So now, since x equals 3 halves is a 0, x minus 3 halves is a factor. And f of x now can be written as x minus 3 halves times what's left over, my quotient, my depressed equation, 2x squared minus 2x minus 6. How are we doing? We're almost done today. I got 2 minutes. I'm not going to quite finish it, but that's okay. So,
yeah, we're doing good.
Good. So I can factor out a 2 there. You can see I've already got my leading coefficient of 2. I get an x squared minus x minus 3. And it's this particular piece that's going to give me irrational roots. All right. So, but how am I going to do that quadratic formula, right? X equals minus b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So it looks like I get other roots of 1 plus or minus square root of 13 all over 2. And so what I like to do when I get these irrational roots is I'll call a the positive rad 13. I'll call b the negative rad 13. And then I can factor into 2 times x minus 3 halves times x minus a times x minus b. Because to write those actual roots in there is hideous. I'm out of time. It's okay. I'm not going to put irrational roots on your test. We're only going to deal with the rational roots. For most of our calculus life, we're going to try and make the things look nice for you. But when you get into applied math, nothing ever looks nice. When you're building a building, you're never going to have a perfect measurement. So you're building all of these things with room for error, right? So the bridge can expand or contract with the weather, kind of thing, right? so it doesn't collapse. All right, we're done today. Have a great weekend. I'm going to, Monday I'll have the test review up for you, and we'll continue.
Have a good one, Professor.
All right, good. Thank you.
Have a nice weekend.
Thank you.
Have a nice weekend.
Thank you.
Hey, Professor.
Yeah, Sean.
Did you say you couldn't stay in for office hours today, or you're busy?
I can give you a couple minutes. I'm a little anxious about getting my test graded, but go ahead. What do you got for me?
I can wait till Monday.
You
if
sure?
You want.
Oh,
Yeah.
that'd be better for me. I'm sorry about that.
No problem. That's fine.
All right, cool.
Have a good
All
weekend.
right, thanks, Sean. You too. Brandon, you okay? You need me? You're muted if you need me, if you're talking. All right, I'll see you Monday. All right, got an hour and a half. Eat breakfast and grade 7 exams. Eat breakfast and grade 7 exams. Okay, Lou? Is it okay if I have to make some portable? I'm really careful about not making a mess, okay? I've tried really hard not to make a mess. Okay. Can I cut you